At the end of the lesson, you are expected to identify regularized least squares, use regularized least squares to penalize overcomplexity, and appreciate the significance of regularized least squares in machine learning. Our previous lesson taught us how to tame an overcomplex model, so we used a validation data to test the efficiency of our training data. So doing all of this can really help us avoid overfitting and underfitting. So for you to be able to get along with this lesson, I suggest you watch our previous lesson so that your understanding of this lesson would be more meaningful. So the description or the link of the previous lesson is given in the description below. So let's consider this mathematical expression. So we have here the function of x with the parameter w, which is equal to w transpose x. So this is actually a matrix representation of our data. So for example, our parameter has the following values. So we have 0, 0, 0, 0, 0, and so on and so forth. So this kind of model is actually really very unusual. This is weird because w just have only one value, and that is 0. Or I mean it has a lot of values, but then all of them are just 0. But then we consider this because it's just very simple, and then this really helps us understand how regularized least squares really works. Okay, so since all the values of w is 0, as you can see in here, then it is expected that this model always predicts 0 values. Maybe you would like to ask me, because everything that is multiplied to 0 is always 0, and this is the reason why our predicted value would always be 0, right? So I think that's very much basic in mathematics. So logically speaking, if we are going to increase the absolute values of w, for example, our w is now equal to 2 or 3 or 4, whatever, the predicted value may also increase. Of course, that is really very expected. And this, in essence, makes our model more complicated. Okay? Maybe you would like to ask me, why is it that it makes our model more complicated? The reason is that we have a lot of values of w that we have to consider, and because of that, we have to deal with them individually with respect to x. Okay, so before we continue, please hit the subscribe button to enjoy more our deep learning, mastering machine learning algorithm, and natural language processing courses. Click the notification bell to receive more updates. So then, what do you think will happen if we set w0? We will take w0 equal to 1. Okay, remember that w0 is our intercept. So we had that in our previous lesson. So this time, it is a non-zero value. So with this new situation, our model will predict a constant. Okay, so along with this new value of w0, which is 1, we can also give w1 a new value. So for example, it could be just 2. It depends. So what do you think will happen if the case is like this? We have a new value for w0, which is a non-zero value, and of course we have a new value for w1, which is of course a non-zero value. So as you can see, we now have a model which is more complex. So this means that if we are going to assign a non-zero value for each parameter, W0 and then W1, or in some cases you will have W2, W3, W4, and so on and so forth, then what will happen is that our model is really becoming more complex. Okay, so as what I've said, we are adding more parameters. The more we add parameters, the more our model becomes more complicated. And also, what we need to always take note of here is that we should consider absolute values. Okay, so I want to write this for you to see and you could not forget. So again, we have to consider the absolute values only. Don't forget the word only. Maybe you would like to ask me, why do we have to consider the absolute values only? The reason for this is that the positive and the negative values will cancel each other. So supposing we have -1 and then we have +1. So -1 plus 1, then this will give us the answer 0. So with this kind of cancellation, then our model may not be able to give us the proper result, because in some cases this will give us a negative value, right? So we do not want this to happen, of course. So with that, we're going to consider using the absolute values. But then using the absolute values is not safe because it has actually some drawbacks. So the problem with this kind of approach is the sum becomes higher. So because -1 plus 1 is equal to 2, because we are considering absolute values, then for example, if you have 20, 10, then it becomes higher. So with this, it becomes hard for us to avoid complexity and even over complexity. So remember that in our lessons, even in our previous lessons we've been talking about, we would like to have a model that is just simple enough to meet our needs, because simplicity really gives us a better time to make some kind of adaptation. Okay, because we have to adapt, we have to manage, and we have to change our models from time to time. And usually when the model is very complicated, this really gives us overfitting, and when it becomes too simple, it gives us underfitting, and overfitting and underfitting really are a problem. So these are the situations that we need to avoid. Okay, so working with over complexity gives us a headache in dealing with big absolute values. Just imagine when you have 10 parameters, when you have 25 parameters. So what kind of headache would that be? But then, nevertheless, the complexity of our model can be defined as, so we have here the summation of W to I. So if we would like to define that using our vector form, then we have W transpose and W. So we had our lessons with regard to how to deal with the different vector forms. What is this for? Why do we have to study this? Having a deeper understanding of complexity guides us on how to avoid problems with our models. So this saves our effort and time. After all being said and done, let's try this. What makes a model overcomplicated? And how should we deal with overcomplicated models? Please leave your answers in the comment below so that we would be able to have a very rich interactions and you and I can learn from each other. Do you want to know more about this course? Just click the card on your right screen. You can enjoy our deep learning, mastering machine learning algorithm, and natural language processing courses. Learn and upskill for free.